Today we're going to look at lesson 3-4. It's talking about rational exponents. And so I'm going to do a lot of problems with you just so that you get the experience understanding the pattern that we're going to use. So for our first part of this, you need to look at, here's a base with a fractional exponent. That's what a rational exponent means. And so all you need to understand is how you go from the exponential form into what's called the radical form. So when we have a fractional exponent, the denominator of that fraction is the index of our radical form. So what this is saying right here is we are taking the nth root of a to the first. And so that would be written as the nth root of a to the first power. So again, this right here became our index, and then if you cover up the index, don't you see a to the first? So a to the first goes underneath and it becomes the radicand. Now what happens if we have something other than 1 in the numerator of that fractional exponent? It doesn't mean anything different. You're still taking the nth root, but of a to the m power. So again, that n becomes our root. So I have the nth root of, and if you cover up that denominator of the fraction, you see a to the m. So that becomes a radicand underneath. And it's that simple. So for the first couple, we're going to look at number 1. I'm going to make these bigger so that we have more room and you can see. All right, so for number 1, just quite simply, we're going to go from this exponential form into radical form. So this 4 is the index. So it becomes the 4th root of, and if you cover up that denominator, you see x to the first. So x to the first goes underneath, and that is all there is to it. Look at number 2, it's a little bit different. This time we have a coefficient and a variable in the parentheses raised to the 1/2. So each of these are independent of the other. So you've got to take that whole base, and you're going to take the second root, which is a square root, of that whole base to the first power. So this is going to equal a square root, so we don't have to put the index in there. And again, if you cover up that denominator, you see 15n to the first power. So the whole 15n goes inside as the radicand. Number 3, 24 is a more complicated base than we had previously. So sometimes you might have to prime factor your base and simplify your radical. So let's go ahead and see what that looks like. So if we took, we're just going to convert this into, sometimes I'll convert it into radical form first, sometimes I'll change the base into exponential form and raise it to this. Let's just convert to radical form right now. So I'm going to cover up that index, and I'm going to have 24 to the first underneath my radical. So I've got the cube root, because that's the denominator of that fractional exponent, of 24 to the first power. So then all you have to do is do what we've talked about before. You're going to simplify the cube root of 24. So if you prime factor 24, you've got 3 times 8, and then by now you should know that 8 is 3 2s. So the cube root of 24 is 2 times 2 times 2 times 3, or you could write 2 to the third power times 3. And then because we have an index of 3, we need a group of 3. So 1, 2 is going to come out in front, and we'll have the 3 left over. So this simplifies as 2 cube root of 3. So using a little bit of prior knowledge. Now, number 4. I want you to do number 4 on your own. So stop the video, try to convert it into radical form. If you can simplify it, do so. If not, then leave it alone. All right, so pause the video. Okay, so here this is our index, right? So I've got the cube root of, and if you cover up that denominator, you see 7 squared. So I'm going to put 7 squared as my radicand. Since I cannot divide 3 into 2, and there's no way we could make a group of 3 with 2 7s, this cannot be simplified. But you have to actually square out that 7 squared. So your final answer would be the cube root of 49. Then I'm going to do number 5, and I'll give you a couple to do on your own. So for number 5, you're going to convert that into radical form and then simplify it. So maybe I'll let you try that one on your own first. So pause the video, try that, see how you do, and then come back and look at the answers. All right, so 2 is going to be our index, so we're just going to put a square root, and then if you cover up that denominator, you've got k to the 7th. So I'm going to put k to the 7th underneath. So that's my radicand. And so because my index is 2, remember one of the ways that we simplified, I mean, you could stretch out 7k's if you want to, but that starts to get really cumbersome. So I'm going to divide that 7 by 2, and if you do your long division off to the side over here, 7 divided by 2. 2 goes into 7 3 whole times. 2 times 3 is 6. That leaves us 1 left over. So we're going to have 3 7s come out in front, and 1 7 will remain. So we're going to have 3 7s, 3 k's coming out in front and 1k remaining. So I've got k to the 3rd, and then we've got the square root of 1k underneath. So I know that previously we have talked about absolute values, and this is a case where we would technically need absolute values around k to the 3rd because it has come out in front of the radical and it's got an odd exponent and it's an even root. But at this point, we're going to allow you to drop and stop doing absolute values. So we're going to let this be our final answer. All right, so then number 8 and number 9, I would like you to do completely on your own. Number 9 is a little bit different, so it's a little bit challenging. Make sure that you notice that on number 9, the 7 is not raised to the 1/2. So this is really like a coefficient in front of all of this. So go ahead and pause the video, try these 2 on your own, see how you do, and then restart the video. All right, so for number 8, remember this is our whole base. So this right here, just the 3, is going to be our index. So I'm going to circle that index, and I'm going to put the 3 where it belongs. And then this entire base is raised to the 2nd power. So if I cover that up, you see negative 6x raised to the 2nd power. So that's what I'm going to put as the radicand, negative 6x raised to the 2nd power. Then you need to perform the math. So we have the cube root of negative 6 squared is positive 36, and x squared is x squared. Then you need to look at this and decide, can I simplify this further? Well, we need groups of 3. 36 is made up of 2 6s, and each of those 6 has a 2 and a 3, so we only have 2 2s and 2 3s. We don't have any groups of 3 in 36, so it doesn't simplify, and there's only 2 x's, so that doesn't simplify. So this becomes our final answer for number 8. All right, then for number 9, this 7 you're not going to do anything with right now. So it becomes 7 parentheses, and instead of this 12w to the 1/2, that 1/2 means it's a square root. So this is our index, so we have a square root. And if you cover that up, your base is 12w to the 1st power, so I don't even need parentheses. I just need 12w. Then we need to simplify the 12. So remember, 12 is 4 times 3. So I'm going to prime factor my 12. And so my 4 becomes 2 and 2 times 3, and then times that w. So I can take out one group of 2's out in front, so there'll be a 2 that gets multiplied to that 7, and then the 3 and the w are going to be left underneath. So 2 times 7 is 14, square root of 3 times w. Good job. All right, let's move on to going in the reverse. So we have taken powers that are raised to a fractional exponent, and we have put them into radical form. Now we're going to go backwards. We're going to go from radical form to exponential form. There are a bunch of ways that you could do this. Here's what I want you to do. So we're just going to follow it backwards. So our base, right here, our radicand becomes our whole base. And then that whole base, remember, is going to be raised to some fraction. Because 16 underneath the radical is raised to the first power, that becomes the numerator. And then the radicand, or the index of the radical, becomes our denominator. So we have 16 raised to the 1/3. But I want you to get in the habit of taking this base, and if it can be prime factored and written in exponential form, you need to do so. So in other words, if you prime factor 16, you should have 4 2's. So 16 prime factors into 2 to the 4th. And currently that 16, which is 2 to the 4th, is raised to the 1/3 power. So this brings us to another rule. We have a power raised to a power. Whenever you have a power to a power, you multiply those exponents. So we're going to multiply 4 times 1/3. And oftentimes I'll do this off to the side. So 4 I'm going to put over 1 because I'm multiplying it to a fraction times 1/3. Nothing cancels diagonally or vertically. So we just multiply straight across. So we get 4 times 1 is 4, and 1 times 3 is 3. And so our final answer is going to be 2 to the 4/3. That is the proper exponential form. All right, so I want you to try, why don't you do number 13? So try 13 on your own, pause the video, and see how you do. Convert it, and then check your answers. Okay, so we see that this is our index, and then this is our base raised to the second power. So I'm going to take that base of 11, and it has some fractional exponent. This 3 becomes the denominator, and this 2 is what our base is raised to, so that becomes the numerator. And because 11 is a prime number, you don't have to factor this at all. So 11 to the 2/3 is completely done, and that is your final answer. So good job if you got that right. What if we have something like number 11 where there's more than one thing underneath that radical? So you can approach this a couple of different ways. You can either separate them or keep them together. It just depends on what we're going to do with that problem later. So for right now, this is my whole base, and it's raised to the first power underneath that radical. And the index you can't see, so it's understood to be a 2. So if we're going to change that from radical form to exponential, we're going to take that same base, which is xy, make sure you leave it in parentheses, and then you're going to raise it to some fractional exponent, because as soon as you have a radical, you should know you have a fraction. So the index 2 becomes your denominator, and what that base is raised to, both of them are raised to a 1, becomes your numerator. So you can leave this as your answer, or you could split it out. So you could raise x to the 1/2 and y to the 1/2 and split it and have x to the 1/2 times y to the 1/2. Either one is acceptable, just depends on where we're going to use that information and how we might write it. So I want you to try number 12 on your own, keeping in mind all that we've talked about bases, because remember, you've got 8 as part of your base, but 8 can be prime factored. So when you're finished converting to exponential form, you may or may not want to change 8 into its prime factored form. All right, so pause the video and try that one on your own. So for this one, 4 is our index. And for right now, you can consider 8w raised to the first power. I'm going to show you a different way that you could view it in a minute. But for right now, you could take that whole, and I got to put it in parentheses, 8w, and you're going to raise it to a fractional exponent. So the index is 4, so that becomes your denominator, and the numerator is 1. So in this particular case, I would probably accept that as an answer. But you could also do it a different way as well. So this is one possible solution. What's another way? So if we looked at the original problem, the 4th root, instead of 8, we could write 8 as 2 to the 3rd, and then times w to the 1st. So we could split this into 2 different radicals, which in some cases might be something that you might want to do. And so then we could convert those individually. So for the first one, our base is 2. And if you look at this, I should, for my fractional exponent, I should be able to see 2 to the 3rd right here. So if I cover up that denominator, I've got 2 to the 3rd because there's my 2 to the 3rd. That index goes down here in the denominator. So 2 to the 3/4, then times my w, and because w is to the first power, the 1 goes in the numerator here, so that if I cover this up, you should see w to the 1st, because there's your w to the 1st, and then 4 goes in the denominator. So we also would accept 2 to the 3/4 times w to the 1/4. As I'm trying to make that look more legible. That didn't work out. I guess I'll keep it the way it was. Okay. Then you need to do 14 and 15 on your own using all that we've talked about. So pause the video, try 14 and 15, and then check your answers. All right, so for 14, you should have k as your base. For your fractional exponent, k is being raised to the 5th, so that goes in the numerator, and the index is 4. And so that's all there is to number 14. So that one was a pretty easy one. For number 15, you have a more complicated base. So the way they've written it, the square root of 3m to the 7th power can be rewritten as the square root of 3m to the 7th underneath that radical. Those are one and the same. And it's actually a lot easier to look at it in this form if I'm going to convert it to exponential form. So my whole base is 3m, and then because I have a radical, I know I have an exponential or a fractional exponent. And so my 3m is raised to the 7th, so that 7 goes up top. And my index is a 2 because it's understood to be 2, so that's going to go in the denominator of that fraction. And so for this particular type of problem, you could leave your answer that way, or I know that some of you may have split it out. So if you split it out, you would have 3 to the 7/2 times m to the 7/2. Either one is acceptable. Either one. All right, last 2 problems on this page that we're going to do. We're going to look at 17 and 18. So these ones are a little bit more complicated. You could approach these in a couple of different ways. I think for our purposes today, we're going to look at, because everything underneath here is raised to a different exponent. So we're just going to look at 10 to the 5th, a to the 3rd, b to the 1st, and we're going to look at that as if it is raised to the 1st power. And then we'll talk about certain situations where we wouldn't want to do it this way. So the index here is understood to be 2. So I'm going to take that whole base, 10 to the 5th, a to the 3rd, b to the 1st. I'm not going to write to the 1st, and I have a fractional exponent. So we're going to take this 1 and put it here, and then the 2, the index, goes underneath. So 1 and then 2. And then if I were you, I'd probably just leave it that way. You could split it up into 10 to the 5/2, because power to power means you multiply exponents, times a to the 3/2 times b to the 1st, so it'd be b to the 1/2. You could split it up. I don't think that there's any necessity to do that. So then you try number 18 on your own. Pause the video. All right, so for number 18, you should have put all of that and raised it to the first power. And so then you have 9x to the 7th, y to the 4th, and then it's going to be raised to the 1 over, and your index is 3, so to the 1/3. That's it. So then let's look at the back page. All right, so on the back side here, it's a little bit more complicated. So these are the steps that we're going to follow here. So if you highlight those, we are going to start by rewriting any radical. We're going to put it into exponential form. Then we're going to use exponent rules, which is why we went over exponent rules at the very beginning, because they're really important. So remember, if you are adding like bases, if you're multiplying like bases, you add the exponents. If you divide like bases, you subtract the exponents. And if you have a power to a power, you multiply those exponents. So those are the basic ones that we're going to use today. Then once you simplify those expressions, you're going to write your answer as a radical in simplest form. Okay, so let's go ahead, and I'm going to do a lot of these problems because the more practice, the merrier. All right, so here we go. So let's look at number 19. So if we are multiplying like bases, we add these exponents. So for note purposes, I want you to go ahead and write out what it is we're doing. So we're going to take x to the 1/3 and add to that exponent the 4/3. So this can be rewritten as this because we're multiplying like bases, so we add those exponents. And what's nice is when you add fractions, remember you have to have like denominators, and in this particular case we do. And so once you have like denominators, you just add the numerators. You do not add those denominators. So we get x, 1 plus 4 is 5/3. And so then we want to put that into radical form, and we want it to be simplified as much as possible. So remember, if I cover this up, that 3 is my index, I'm going to have x to the 5th underneath. So this is equal to the 3rd root of x to the 5th. And if we are to simplify that, we are going to take this index here and divide it into the 5, and so we'll do that off to the side. So 5 divided by 3, 3 goes in there once with 2 left over. So that means that I have 1x that's going to come outside and 2 x's that are going to remain. And I'm just putting rem for remain. And so my final simplified answer is going to be 1x out in front. Don't forget your cube root, and then 2 x's are left inside. And again, remember, we're allowing you to drop using absolute values. This wouldn't need it anyway because it's an odd root, but you won't hear me talking about them anymore. All right, so what happens if we're multiplying like bases and we add those exponents and we have unlike denominators? So you have an option. You can find the least common denominator or just multiply these together. So our least common denominator is 4. I can multiply 2 by something to get 4. If you don't know how to find least common denominators, you could just multiply 4 times 2 is 8 and make them both into 8. But you can talk to me about that later because I'm not going to show you to do it that way. We're going to use greatest common or least common denominator. So this becomes p to the 1/4 plus 3/2. If my least common denominator is 4, the first fraction has it. The second fraction, I would have to multiply the denominator by 2 to get 4. And if I multiply that denominator by 2, I have to multiply the numerator by 2. You must multiply by a form of 1 so that you don't change the value of that fraction. We're giving it a little bit of a facelift, but we're not changing its value. It's still the same. So we get p to the 1/4 plus 3 times 2 is 6, 2 times 2 is 4. Now we have like denominators and we can add those exponents, or those numerators. So 1 plus 6 is 7. So I get p to the 7 over 4. And then finally you have to put it back into radical form. So remember, this is our index. So I have the 4th root of p to the 7th, and then we have to simplify that. So I'm going to take and divide 7 by 4. So I'm going to do that off to the side. 7 divided by 4. 4 goes into 7 once with 3 remaining. So we're going to have 1 p come outside and 3 p's are going to remain. So 1 p comes out, don't forget your 4th root, and 3 p's are going to remain. All right, so let's look at number 21. So for 21, we have a different rule going on here. We are dividing like bases. So when we divide like bases, we want to divide where there are more. So to determine which fraction is larger, you're going to have to get a common denominator. So again, I have a denominator of 2 and a denominator of 4. The least common denominator is 4. So this one has it. I don't need to change it. But I do need to change this one by multiplying top and bottom of that fraction by 2. So I get m 5 times 2 is 10, over 2 times 2 is 4, divided by m to the 7/4. So now 10/4 is larger than 7/4. So now I know that I'm going to take this entire denominator and subtract it up in the numerator. And since I'm canceling all of this down here, there'll be 1 left in the denominator. We don't write things over 1. So it just becomes m, 10 minus 7 is 3, 4. Now the nice thing is 4 does not go into 3, so we won't be able to simplify our radical, so we're just going to put it into radical form. So our final answer is going to be 4th root of m to the 3rd. How did I get that? Remember, if you cover this up, that becomes our index, so there's our index. If I cover that up, you can see m to the 3rd should be underneath as your radicand. And so this is our final answer. Okay, the last rule that I want to talk about is power to power. So number 22 has a power, base and an exponent, raised to another power. So with power to power, the rule is that you multiply those exponents. So I have a to the 1/3 times 5/2. So what you might want to do is put these rules on flashcards and study them if you don't know your exponent rules. It's going to come back to bite you if you don't know them. So multiply across. 1 times 5 is 5. So I get a to the 5th over 3 times 2 is 6. The nice thing is 6 does not divide into 5. So when we convert this, we will not have to simplify. So 6 is our index. So the 6th root of a to the 5th. And again, that 6 became our index. If you cover it up, you should see a to the 5th, which becomes your radicand. And so this is our answer for that one. All right, so now I'm going to do 23 for you, and then you'll do 24 on your own. And I'm doing 23 because it's weird. It's a little odd. We do have a power to a power. So the first thing I'm going to do is I'm going to take this base of 32 and I'm going to multiply the power to power. That would be the easiest. So we get 32, and then to the 1/2 times 1/2. So it becomes 32 to the 1/4. If I were you, I would take this base of 32 and convert it to its exponential form. And so if you recall, prime factoring 32, I get 5 2's. So I'm going to replace the base of 32. So instead of 32, I'm going to have 2 to the 5th. But remember that base of 32 is being raised to the 1/4. So we have another power to a power situation, and we needed to do that in order to simplify our final radical. It'd be easiest. So we're going to take this. So we end up with 2 to the, and that 5th becomes 5/1 times 1/4, which equals 2 to the 5/4 All right, so then I'm going to rewrite that. Well, actually, I'm going to leave that 2 to the 5/4 because I'm going to figure out how many 2's stay under the radical and how many 2's come out. So I'm going to take 5 and divide it by 4. So 4 goes into 5 once with 1 left over. So that means I'm going to have a 2 come out and a 2 remaining. So when I write my final answer, I get the 4th root, let me put my 2 that's on the outside. So I have a 2 that's coming on the outside, and then I have my 4th root, and I have a 2 that's left on the inside. So for 24, I would like you to try that one on your own. Remember, this is a more complicated base, so the whole 8x squared is your base. So I guess you could, instead of having, I'm going to get you started and then I'll let you stop the video. So let's look at just the 8 here right now. Let's just split this. Might be easier if you split this one. So you have 8 to the 1st right now, right? So if I were you, I would take 8, and then you got a power to a power, so you're going to multiply 1 times 2/3. So you've got 8 to the 2/3 times x squared. Well, yeah, I'll do it out long ways. So I'm going to take x to the 2 over 1 times 2/3. So really what you have, and then on top of that, I'm going to change 8 into, so I'm going to take this 8 and change it into its exponential form. So I actually have 2 to the 3rd, and I'm going to raise that to the 2/3 times, and then I guess I'm going to do this one for you. I'll give you another one to do on your own. All right, so then we got 2 times 2 is 4, and 1 times 3 is 3. So we've got x to the 4/3. And then before I move into radical form, let's go ahead and finish simplifying. So I'm going to put, because this is another power to power over here, right? So I've got 3 times 2/3, but what I want you to notice when I multiply 3 over 1 times 2 over 3, an interesting thing happens. Don't the 3's cancel? So we end up with just 2 squared, okay? So the 8 to the 2/3 became just 2 squared because power to power multiply, those 3's canceled and you're left with 2 to the 2nd. So there's 2 squared times x to the 4/3. So that I can put into radical form because it's a fraction. So I've got the 3 is my cube root, it's my index, and then I'll have x to the 4th. So remember, I covered up that 3, that's where the x to the 4th came from, and that 3 became my index. Now I can actually divide 4 by 3, so let's do that. So 4 divided by 3, 3 goes in there once with 1 left over. So I'm going to bring an x out in front of the radical, and 1x will remain. So I have 2 squared, which is 4. I'm going to bring an x out in front of my cube root, and then an x will remain. So again, that 2 squared became 4. Then we took 1x out in front, and we had 1x remaining, and it's still a cube root. So number 26 is fun. I find it fun because, again, you have like bases. So you want to add the exponents, and these exponents have like denominators. So I'm going to take 16 to the 2/3 plus a negative 1/3. So that negative should really be looked at as if it's in the numerator. So I have a 2 plus a negative 1, which gives me a positive 1. So I have 16 to the 1/3. If I were you, I would change 16 into its prime factored form. So I'm going to take that 16 that's raised to the 1/3, and I'm going to take that 16 and put its prime factored form in here. So if you prime factor 16, you should have 2 to the 4th. So now I have a power to a power. We multiply exponents. So I have 2 to the 4/1 times 1/3. Nothing cancels diagonally or vertically. So you just multiply across. So I have 2 to the 4/3. So now I can put that into radical form. The 3 becomes my index. And then I have 2 to the 4th underneath. So again, you're covering up that 3, and you can see 2 to the 4th goes underneath, and that 3 becomes your index. So somewhere off to the side, you're going to take 4 and divide it by 3. 3 goes in there once with 1 left over. So you're going to have 1, 2 that's going to come out in front, and 1, 2 is going to remain underneath. So our final answer is 1, 2 out in front, cube root 1, 2 remains. All right, so next we're going to look at number 27. And so for number 27, we have something that's a little bit different. We have a negative in the exponent. So if you remember, when you have a negative, you want to take the reciprocal of the base and its power. So I'm going to deal with that negative first, the negative that's in the exponent. We'll deal with the negative that's in the base next. So this becomes 1 over negative 216 raised to the positive 1/3 power. Then we're going to convert this to, we're going to actually convert 216 into its exponential form. So we're going to use, it's not one of our normal numbers, so I'm going to ignore the negative. And I'm going to start with 4, because I know that 4 goes into 16, so 4 should go into the number. So 4 goes into 21 5 times with 1 left over, and 4 goes into 16 4 times. And so then 4 becomes 2 and 2, and 54 becomes 9 and 6, and we have 3 and 3, and 2 and 6, or I'm sorry, 2 and 3. So I actually have 1 over, and then I have a negative 1 times, and then we have 3 2's, so 2 to the 3rd, and 3 3's, 3 to the 3rd. And all of this is raised to the 1/3 power. All right, so I'm going to come back over here. So then we have 1 over, and we know that this negative here is being raised to the 1/3 power. So this negative 1 raised to the 1/3 power means we're taking the cube root of negative 1. So the cube root of negative 1 is negative 1. So I know that that's going to come out to be negative 1. And then I want to raise 2 to the 3rd to the 1/3. So power to a power, we're going to multiply those exponents. And so 3 times 1/3 is 1. So for this one right here, I end up with 2 to the 1st. And then finally, 3 to the 3rd, again, we're going to do power to power, so multiply exponents. So 3 times 1/3 also is 1. So times 3 to the 1st. And so our final answer becomes negative 1 over 1 times 2 times 3 is 6. And so our final answer is negative 1/6. You could have changed this right here into its radical form and rewritten this as the 1 over the cube root of negative 216 and then prime factored from there, and then circled your groups of 3's. So that is an alternative method to solving that particular one. So then I would like you to try, let's see, let's have you do number 28 on your own. So pause the video, do number 28. And one thing I'll remind you of, if you raise 112 to the negative 1/4 power, you also have to raise 7 to the negative 1/4 power. And then to take care of that negative exponent, take the reciprocal of the base. So the reciprocal of the base is 7 over 112. When you actually take that reciprocal, this power becomes positive. All right, so pause that video. All right, so to take care of this negative, right here, we're going to take the reciprocal of this base. And so I get 7 over 112 raised to the positive 1/4. So then I can split a fraction. This 7 and this 112 are both raised to the first power. So 1 times 1/4, 1 times 1/4, they're both 1/4. So I have 7 to the 1/4. And actually it would behoove us, which means to benefit us, to actually see if 7 divides into 112. Since they're both being raised to the 1/4, if I can reduce this fraction, I should. And I have a feeling that 112 is divisible by 7. So 7 goes into 11 once. And sure enough, here we go. With 4 left over, bring down the 2. 7 goes into 42 6 times with no remainder. So that means that 7 goes into 7 once, and 7 goes into 112 16 times. That makes our life a whole lot easier. So the next thing I'm going to do is I am going to raise 1 to the 1/4. So I'm going to split these up, and then 16 to the 1/4. I prefer to have my bases in their prime factored form. So remember, 16 is made up of 4 2's. So I get 1 to the 1/4 over 2 to the 1/4. Or I'm sorry, 16 is 2 to the 4th. And that is raised to the 1/4. So all I did is take 16 and replace it with 2 to the 4th. But it's still raised to the 1/4. So this one right here is saying, remember your denominator here in the exponent is 4, so it's saying the 4th root of 1 to the 1st, which is equal to 1. And then this one here, the denominator, we've got 2 to the 4 over 1 times 1 over 4. So I'm writing that out so you can see it, and note how those cancel. And I end up with 2 to the 1st power, so that means that all of this simplifies to just 1/2. All right, so then let's look at 29. So 29 is just V's, and you'll notice that this index is different than this index. So this means that we have a little bit of a different situation. Normally we can't multiply, unlike radical indexes. So we can get around that by changing each of these radicals into their exponential form. So this is v to the 1st and v to the 1st. So for each one of these, I've got v to the 1 over 3, so 1/3, times v to the 1 over 2, because that index is understood to be 2, so 1/2. Then we are multiplying like bases, so we can add the exponents. Since the denominators of my exponents are 3 and 2, I need to find the least common denominator, and the least common denominator in this case is 6. So I have to multiply 3 by 2 to make it into a 6. So if I multiply the denominator by 2, I have to multiply the numerator by 2. Same thing for this one. I have to multiply 2 by 3 for it to become 6. So if I multiply the denominator by 3 and the numerator by 3, I'm multiplying both of these by a form of 1. So I'm not changing their value, I'm just giving them a facelift. So I end up with v to the 2 over 6 times v to the 3 over 6. Now I can add their exponents. So I've got 2/6 plus 3/6 equals v to the 5/6. And since 6 does not divide into 5, I won't be able to simplify my radical, but I can take it out of radical form. So this 6 becomes my index, and if I cover that up, v to the 5th will be underneath the radical. So 6th root of v to the 5th. So now we have a way of taking two unlike indexes and multiplying them by using our exponential form. All right, so what I would like you to do is try number 30 on your own. So pause the video, try number 30, and then restart the video. So on this one, our r on the second one is raised to the first power, and its index is 2. So to take these out of radical form and into exponential form, the first one becomes r to the 3/4 times, and the second one becomes r to the 1/4, or I'm sorry, 1/2. Our LCD, least common denominator, is 4. So this first denominator has it, but this one needs to be multiplied by 2. So if I multiply the denominator by 2, I have to multiply the numerator by 2. And so I get r to the 3/4 times r to the 2/4, and I'm multiplying like bases, so I add their exponents. And so I get r to the 5/4. Now this time I will be able to divide. 5 is divisible by 4. So I'm going to do that off to the side. 5 is divisible by 4. So 4 goes into 5 once with 1 left over. And so what that means is I'm going to have 1 r on the outside and 1 r will remain. So this becomes the 4th root of r to the 5th, which equals, remember, we have 1 r comes out, 1 r remains, because we want groups of 4. So 1 r comes out in front, the 4th root of a single r. So if you forgot to simplify it, make sure you fix that. All right, and so then we only have 3 more. So let's look at 32. So here's the great thing about 32. If you are dividing like bases, and they're underneath the same radical, if we recall, previously we can put these under one radical. And this is 7 to the 1st. If I divide like bases, I subtract their exponents where there are more. So all of this denominator is going to subtract up here in the numerator. And I end up with the square root of 7 squared. And then there's only 1 in the denominator, and the square root of that is 1. And so you can either look at this as you're taking the index and dividing it by 2, or you can just square your 7, which you get 49. The square root of 49 is 7. So either way you go about it, the answer to 32 is 7. So then I'm going to have you do 33. So pause the video, try 33. This doesn't look any different than when we were simplifying radicals, so maybe let's just talk about this one first. So remember, this is my index, and then this is going to be the numerator of my exponent. If you take this out of radical form, so x to the 10 over 4, 10/4 actually reduces. You can divide 10 and 4 by 2. So divide each of these by 2 and you get 5 over 2. So this actually equals x to the 5/2. And you can actually divide 5 by 2. 2 goes into 5 2 times, and I get 4. Subtract and I get 1. So we're going to have 2 x's that come outside and 1 x that remains. And you could have done that by dividing 10 by 4, and you should have gotten the same answer. And let's just check that. So if we went over here and did 10 divided by 4, four goes into 10 twice. 4 times 2 is 8. 2 remaining. But, so you would have, just like we had before, you would have 2 that would go on the outside, and then 2 would be remaining. Well, those 2 would remain underneath a 4th root. So you would have the 4th root of x squared, which is x to the 2/4, which can be reduced to x to the 1/2. So our preference is, this is the more simplified version, which would then be the square root of x. And so our preference is that you do it this way, because otherwise this is going to end up being your answer. And actually, let me take out what's in front. So you would have had 2 x's out in front here, right? And then only this part right here becomes this, which is then this. So technically your answer should be x squared, square root of x. So otherwise you would have left this as your answer, when in reality this is the correct answer. So let's go ahead and convert that into its radical form. So if you cover up this 2, which is your index, you've got x to the 5th. Oh, well, we already divided out here, right? So we're going to have, right here is where we divided 5 by 2. So we're going to have 2 x's come out and 1 remaining. So we end up with an x squared out in front, and then our index is a square root, and so we have 1 remaining. So as you can see, this is the most accurate answer. All right, last one, I promise. All right, so for this last one, you are going to convert each of these into exponential form. And I'm going to prime factor the 25, so that's 5 squared, and then m squared. You could rewrite this as the 4th root of 5m, all of that squared. Since both of these are raised to the 2nd power, you can write them both as the base raised to the 2nd power, and that would actually make it easier. If you convert it, take the base of 5m, and then we have the 2 here goes in the numerator, and the index 4 here goes in the denominator, and 2/4 reduces to 1/2, and so our final answer, I'm going to put it down here, would be the square root of 5m. And so again, if you had tried to leave your answer this way, you would have said, oh, well, I can't divide 2 by 4. Well, that's not possible. So I'm just going to leave this as my answer. When in reality, this is the proper, fully simplified answer. All right, so good luck with your homework. Let us know if you have questions.